Guys, welcome to my channel Patantaracha Yukta Means Learning Tricks. My name is Akshay Jedhe and today we will discuss about contactless electrical tachometer. So let's understand this diagram first. So this is a rotor, toothed rotor, and this is a permanent magnet, and the coil is wound around this permanent magnet. When current is passing through this permanent magnet, the magnetic field produced around this permanent magnet, and when this rotor is rotated, okay, this rotor is mounted on the shaft whose speed we have to measure. We know that tachometer used to measure the speed of the shaft. So this rotor comes in between the magnetic flux in magnetic field. So as this rotor rotates in the magnetic field, magnetic flux generated and these pulses are generated. Okay, so these are the pulses which is generated, and this is nothing but the amplifier or shaper. This is used to amplify the frequency of this pulse and shaped into square waves and given to the frequency meter to measure the speed of the shaft. Okay, this is nothing but the construction and working of contactless electrical tachometer. So how we can find the number of rotation? So there is a formula: pulse per minute divided by number of teeth on the rotor. So this tachometer is used to measure the speed range between 7 to 2000 rotation per minute. So now second type is capacitance tachometer. Okay, this is a second type of contactless electrical tachometer. This is nothing but capacitance tachometer. So in this is a shaft which is rotating in clockwise direction, and this is a vane which is attached to the shaft. As the shaft rotates, vane also rotate between the two capacitance plates, and due to which pulses are generated, and this is nothing but the amplifier shaper which is used to amplify the frequency of this pulse and shaped into square pulses and given to the frequency meter to measure the rotation of the shaft in RPM. So let's understand the main point about this tachometer. In this type tachometer, capacitor circuit is placed of an inductive circuit. Means capacitive circuit is used in the place of inductive circuit. Okay, then vane is attached to the rotating shaft. As vane rotates in between the capacitive plates, capacitor is a part of oscillator system such that number of frequency changes per unit time is measure of shaft. Means due to vane rotates between the capacitance plates, due to which the pulses are generated, and this is used to measure the speed of the shaft in rotation per minute. So fourth point is pulses which are produced, they are amplified and shaped, then feed to the frequency measuring unit to give the measure of the shaft in rotation per minute. Okay, then the third type of tachometer is photoelectric tachometer. So in this type of tachometer, as we can see, this is a disc. This is nothing but the rotating opaque disc, and this is a photoelectric sensor. This is a rotating shaft. So in this type of tachometer, this disc is mounted on the rotating shaft to measure the speed of this shaft, and this is a light source. So let's understand this is a nothing but the diagram and construction of this photoelectric tachometer. Let's understand the working of this tachometer. So photoelectric tachometer uses an opaque disc mounted on a shaft whose speed is to be measured. Okay, photoelectric sensor used to measure the rotation per minute. Means this photoelectric sensor is used to measure the speed of the shaft in rotation per minute. So as we can see, opaque disc has equispace holes on its periphery with opaque spaces between these holes. See, these discs having the holes in equispace, means with equal distance in between them, and this is an opaque space. Okay, this is nothing but the meaning of this statement. The number of pulses generated depends on the number of holes in the disc and rotation per minute of the shaft. Okay, now therefore holes are fixed, then frequency of pulses sensed can be directly calibrated to give the rotation per minute of the shafts. Okay, so in this type of tachometer, these holes on the disc are fixed So as shaft rotates, this disc also rotates. When this photoelectric sensor and light come in straight line, then this opaque specs come between this, then sensor light is stopped. Then again this light and this hole and this photoelectric sensor come in one line. Okay, this is how on and off photoelectric tachometer works, and this measures the rotating shaft speed in rotation per minute. So after that, the last type is digital tachometer. This is nothing but the digital tachometer diagram, and this is a on and off power button, and this is a memory card. So let's understand the digital tachometer with some points. Digital tachometer is a handheld non-contact type precision meter for measurement of rotating speed. Means in this type of digital tachometer, one laser beam is used to measure the speed of the shaft without directly in contact with the rotating shaft. Okay, memory button is used to save the previously recorded reading. So as we can see in this diagram, memory button is used to save the previously recorded reading. Okay, so how we can operate this digital tachometer? So this is a procedure to use the digital tachometer. Apply a marker to the object whose RPM is to be measured. Means suppose we want to measure the speed of the shaft, so we have to mark some point on the shaft. So this is the first point, apply the marker on the object whose speed we have to measure. So second point is bring the tachometer in line with the marker at a distance of 50 to 150 millimeter. This is a second step. And the third step is press the measure button to measure the speed of the shaft. Verify monitor lamp lights up which time target passes through the light beam. Means verify this working is going good or not. So release the measure switch when reading is stabilized. So these are the 5 steps to operate the digital tachometer. So here is the note why we use marker for in this digital tachometer. So if marker is put on the rotating member and light from an LED or laser source in the meter is focused on this marker, means marker and laser light are in one line. Any time marker comes in contact with the light beam is interrupted and signal pulse to generated. The marker serves as a on-off switch. So this statement you can understand this by this simple diagram. Suppose this is a digital tachometer and this is a shaft whose speed we have to measure, and this is a front part of the shaft. I am zoom it to here to show the how it is working. Suppose this is a marker and this is a digital tachometer. This is in one line. So when as this shaft rotates, this front view of the shaft also rotates. When light and this marker comes in contact with, then laser light do not recognize the rotation. So at this time laser light is off. When this rotates again, then this is a one new rotation. So this is nothing but the marker is used as the on-off switch for every single rotation. Means when marker and laser light come in between in one line, then this is the ending of the one cycle and starting of the another cycle. So marker is used as a on-off switch in digital tachometer. So this is nothing but my try to give you the some important definition and information about the tachometer. If you like this video, please like, share and subscribe to my channel, and if you have any doubt to please free to comment down below. Thank you.